display of motion in chain along with sprocket through Inventor Studio. In this exercise, here three pre-constructed parts are selected for use. One is chain link and the other two parts are sprocket large and sprocket small. Part files are available on the following blog. Create a new standard part file. At present, Sketch 1 is active by default. Use the Finish Sketch command to exit from sketching mode. Open the visibility of YZ workplane under the origin folder in the browser bar. Create a new workplane parallel to YZ plane at an offset distance of 320 mm. Create a new sketch on XY plane. Draw a circle of 100 mm diameter, coincident with the auto-projected part origin. Create another circle of 75 mm diameter. The distance between these two circles will be 320 mm. Take the project of x-axis and convert it to construction geometry. The center of a small circle will be 12.5 mm below the projected x-axis line. Draw a line connecting top of two circles as displayed. Draw another line between two circles. Apply a horizontal constraint on it. Erase the unwanted sketches by using Trim tool. Apply dimensions as displayed to fully constrain the sketch. Take the project of YZ plane and work plane 1 from the browser bar with the use of Project Geometry tool. Convert these projected lines into construction geometry. Apply a dimension between these projected lines. This dimension will be driven dimension. Now the sketch is complete. Exit the sketch environment. Create a work point at the intersection of YZ plane and bottom line of the sketch. Activate the Parameters tool from the Parameters panel of the Manage tab. Create a user-defined parameter named Start by clicking Add Numeric button in the Parameters dialog box. Click the equation column and then select the driven dimension in the design window. Click Done. Save the part file with the name master. Start the rectangular pattern tool and select work point 1 in the browse bar. Click Direction 1 button and select the sketch in the design window. In the column spacing input box, click arrow button to expand choices. Select list parameters, then select the start. Click more button to expand the dialog box. Select adjust in the compute option. Click the Start button in the Direction 1 field and select the work point 1 in the browse bar. Click OK. Open the visibility of Sketch 2 from the browser bar. Select Work Plane 1 in the browse bar and make it adaptive from the context menu. Activate Rectangular Pattern tool once again. Select Work Point 2 in the browse bar. Click the Direction 1 button and select the sketch in the design window. In the column count input box, enter the value 61. Click this drop down to specify pattern length. Select Curve Length option. Click the More button to expand the dialog box. Select Adjust in the Compute option. Click the Start button in the Direction 1 field and select the work point 2. Select Direction 1 in the Orientation option. Click OK. Save the file and close it. Create a standard assembly and save it with the name Chain Inventor Studio. Select Place Component tool from the marking menu and place the master part in the assembly. Select the master sketch from the browser bar. Right click and deselect Grounded from the context menu. Select the master sketch again and make it adaptive from the context menu. Align the model in appropriate position using the view cube. Apply a flush mate between YZ plane of assembly and YZ plane of master sketch. Apply a flush mate between XZ plane of assembly and XZ plane of master sketch. Apply a flush mate between XY plane of assembly and XY plane of master sketch. Apply a mate constraint between YZ plane of assembly and work plane 1 of master sketch. Enter the value 320 mm in the offset input box. Click OK. Select Place Component tool from the marking menu and place the chain link in the assembly. Set the browser from assembly view to modeling view using the toggle at the top of the browser. Apply a mate constraint between center point of chain link and work point 2 of master sketch. Change the view of design window by using view cube. Align the chain link in correct position by using rotate component tool. Apply a mate constraint between XY plane of assembly and XZ plane of chain link. Apply angle constraint between XZ plane of assembly and XY plane of chain link. Select directed angle option in the solution field. Now chain link is fully constrained in the assembly. Start the pattern component tool from the component panel of assembly tab. Select the chain link as component. Then select rectangular pattern 2 of master sketch in the browser bar as associative feature pattern. Click OK. Now all the chain links are fitted on the curve loop. Close the visibility of work planes visible in the design window. Select Place Component from the marking menu and place the small sprocket in the assembly. Create a work axis in the assembly on this point parallel to z-axis of the assembly. Apply a mate constraint between axis of small sprocket and newly created work axis of the assembly. Apply a mate constraint between XY plane of assembly and mid plane of the small sprocket. Select Place component from the marking menu and place the large sprocket in the assembly. Apply a mate constraint between axis of large sprocket and z-axis of the assembly. Apply a mate constraint between XY plane of assembly and mid plane of the large sprocket. Change the view of design window by using View Cube. Activate motion constraint command. First select axis of large sprocket and then select axis of small sprocket. Click OK. Apply an angle constraint between XZ plane of assembly and YZ plane of large sprocket. Select Directed Angle option in the Solution field. Change the name of Mate 1 constraint to Drive 1 and Angle 3 constraint to Drive 2 in the browser bar. Click the Inventor Studio icon from the Begin panel of Environments tab. Select Drive 1 constraint of master part in the browser bar. Right-click and select Animate constraint in the context menu. In the Time section of Animate Constraint dialog box, enter the value 30 seconds in the End input box. In Action section, enter the value 1 mm in the End input box. Click Acceleration tab. Select Constant Speed Radio button in the velocity profile. Click OK. Select Expand Action Editor button on the animation timeline. Select Drive to Angle constraint of large sprocket in the browser bar. Right-click and select Animate constraint in the context menu. In the Action section of Animate Constraint dialog box, enter the value minus 360 degree in the End input box. In the Time section, click the Specify Start Time button. Click Acceleration tab. Select Constant Speed Radio button in the velocity profile. Click OK. Select Collapse Action Editor button on the animation timeline. Click Animation Options button. In the Animation Options dialog box, select Constant Speed Radio button in the default velocity profile. Click OK. Close the visibility of all the sketches and work features. Clear the screen by activating the Clean Screen command. Click Go to Start button. Click Play Animation button. We invite all of you to visit our blog, where you may get similar screencast videos. Please keep watching our videos. Goodbye.